Okay, so when we look at the spell work here, there's about 3 problems, and we're going to start out with this multiplication problem. So multiplying 2 rational functions, or you can think of it multiplying 2 fractions here. Now, when we multiply fractions, we multiply straight across. By the way, heads up, this problem is similar to the problem on packet 12, page 1, number 4. So if you're having trouble with that problem, stick around with this, watch me do this problem, and then try out the one on the packet. So to do this problem here, we would multiply straight across, but we learned in Journal 56 that you can cancel out factors if they're the same top and bottom, so vertically. So you can cancel out vertically, and you can cancel out diagonally, okay? So when I look at this here, I can already see that 27 and 3, those two diagonally have numbers that can divide into 27 and 3. So what divides into 27 and 3? Well, 3 can divide into 27 9 times. So I'm going to cancel that out and replace it with a 9. And 3 can divide into 3 1 time. So I'm going to just cross out that number and replace it with whatever number you can divide by. Why do I do this? Well, because what happens is I'm reducing the number down to a smaller number, and that's going to make it easier to multiply later. So now let's take a look at the variables. You have an x here and you have an x here. So for variables, you have to look at the power. This power is a 4, this power is a 6. You can cancel out the smaller power. The smaller power out of these two is x to the 4. So that means I can cancel that out or cross it out, but that means I took away 4 x's in the top. So that means for the bottom, I have to take away 4 x's from this 6. So this 6 here, I would subtract that by 4 and replace it with a 2. 6 minus 4 gives me 2. And so now I just have x to the second power. Okay, now let's take a look at these y's here. This is y to the second power, whereas this y diagonal from it is y to the first power. Now, y to the first power is smaller, so I'm going to cancel that out, but that means I took away 1 y here, so I have to take away a 1 from this 2. So I'm going to cross that out, replace it with, well, 2 minus 1 is just 1. And so now this is y to the first power. Okay, so I took care of this diagonal. Maybe I should look into this diagonal here. Like 4 and 24. What divides into 4 and 24? Well, 4 can divide into 4 1 time, and 4 can divide into 24 6 times. So I can replace the numbers with what it divides by, which is 4. And then this x here is to the first power, whereas the other x diagonal from it is x to the fifth power. So this x is smaller, so I'm going to cross that out, and I'm going to subtract 5 from 1, 5 subtract by 1 is 4. So now I'm left with x to the fourth power. Now I'm going to take a look at the z's. This is z squared, whereas this is z to the third power. So z squared is smaller, so I'm going to cancel that out. 3 minus 2 on this z would give me 1. Okay, let's write down what we have. So this here, I have a 9. X to the fourth got canceled, and the y to the first power got canceled. So I just have a 9. And in this bottom here, I have a 1. The x got canceled, the z got canceled. So I just have a 1. Notice how I took all of this stuff and changed it to 9 over 1, because that's what happens when you cancel out factors. You get to see a lot of things get wiped out. So now let's take a look on this side here. You have a 6 instead of a 24. You have x to the fourth power and z to the first power. So x to the fourth power, z to the first power. And in the bottom here, I have a 1, x squared, and y to the first power. So 1x squared, y to the first power. And now when I look at this here, it's going to be a lot easier to multiply, like 9 times 6, if I multiply this straight across. 9 times 6 gives me 54, x to the fourth, z to the first power. So I don't have to write that 1 if this is z to the first power. That's redundant. So that's the top. I've just multiplied. The bottom, 1 times this is just going to be 1x squared, y to the first power. But hold up, I don't think I'm done yet. Remember, we can cancel out things diagonally and vertically. So what I noticed is that when I wrote this down, I had two x's in the top and bottom. Why not just cancel out the smaller one? So the bottom here is x squared, so that gets canceled. So that means I took away two x's here, so I have to take away 2 from this 4. So this 4 is now a 2 because 4 minus 2 gives you 2. Okay, so looking at this, I have 54 in the top, x squared in the top, z over 1 times y is just y, right? I don't have to write that one, so I just have a y in the bottom. And that's it. That's my final answer. I made all of this yucky stuff became this much cleaner rational function. Okay, so I hope that helps you out. If you haven't done problem 4 on that page 1 of packet 12, try to do that now. Okay, so I'm going to move along to adding and subtracting fractions. When we add fraction, there's something very important that we must do before we can add the fractions, and that is finding a common denominator. So we have to find common denominators before we can combine the fraction. Okay, so when I'm looking at this fraction and this fraction, I have to figure out what can 8 and 4 both be. Well, I know that 4 can be an 8 if I multiply this 4 by 2. So I'm going to choose my common denominator to be 8. So I wrote an 8 down. And so I need to multiply this 4 by 2 to do it, but anything I multiply to the bottom, I have to multiply to the top, so the 3 also gets multiplied by 2. Now when I look at this fraction here, I don't need to multiply it by anything, because on the common denominator that we chose is 8, and this is already 8, so I can just leave this fraction alone. Okay, so I'm going to take this 2, add it with 3 times 2. So I'm going to have a 2 plus, because there's a plus sign here, so I brought the 2 over, I brought the plus sign over. 3 times 2 gives me 6. By the way, I've seen people write this as 2 separate fractions. Like they'll write 2 over 8 and then 6 over 8 and then add the fractions. I just like to write it all in one fraction. So when I'm looking at this here, if I add these two, I get 8 over 8, which is just 1 if I reduce. So my answer is just 1. Okay, so now that we've gotten a little bit familiar with common denominators, let's try out this one here. This one I'm subtracting, but subtracting is the same. You need to find a common denominator. So this one's a 3, this one's a 5. What can 5 and 3 both be? Well, in this case, 15 might be a good choice to choose as our common denominator. So if I choose 15, I have to multiply this 3 by 5. So that's what I'm going to do. I'm going to multiply this 3 by 5, so I have to multiply the top by 5. This 5 needs to be multiplied by a 3 to make it a 15, so I have to multiply the top by 3. So you never really see me multiply the bottom, because if I multiply the bottom, I get 15, and this one would also be 15. So I already wrote that when I started writing my common denominator. But I do need to multiply in the top. So 5 times 10 gives me 50. Then there's a minus sign in between them, so I'm going to carry that over. And then 4 times 3 gives me 12. I'm going to write that in. Okay, so if I simplify the numerator here, 50 minus 12 is 38 over 15. If I try to reduce, I don't think I can. So this is my final answer. So next, keep these skills in mind, because we will be adding and subtracting fractions today, or what we call rational functions. So keep in mind those finding common denominators. We're going to need that here in a sec. Okay, so when you're adding rational functions, you got to make sure that the denominator are both the same. So you got to have common denominators before you can add. So take a look at part A. Notice how the bottom here are exactly the same. They're both x squared plus 4x minus 12. So because they're already the same, I don't have to find a common denominator because it already is the same denominator for both. So that's what I'm going to choose my common denominator to be. So I'm just going to choose this, so copy, paste. That means that because they are the same, already the same, I can add the top. So I'm just going to add like terms or combine like terms for the numerator now. So like x plus 2x gives me 3x, right? Like I can group up these two. And then I have a negative 3 plus 4, which gives me plus 1. And that's it. That's all I could do. So this is my answer. Okay, now let's try B, where notice that the denominator here are not the same at all. So in this situation, you do need to find a common denominator. So our common denominator, we can think of it as kind of like the problem in the bell work. So when you look at this bottom here, you have x plus 2 and x plus 5, and they're completely different from each other. So think of these as like factors. And so your denominator, you need an x plus 2 and an x plus 5. Okay? It's kind of like that problem in the bell work when you had like, let me write this out. I think it was something like 3 in the bottom, and then there was a 5 here. I'll just make it up. Put this as a 4. So when we were adding these, we chose this to be like 15, right? The common denominator to be 15. But that's also because we took 3 and 5 and we multiplied it, right? To get that 15. That's exactly what we're doing here. We're taking these two factors and we're setting them next to each other in a way that they're multiplying each other. So what you do to find common denominators when you have completely two different things is take the factor of the denominators and write one copy of it for your common. Okay, so I'm going to erase this part here. So when we look at this denominator here, we have to figure out what to multiply, or what is this denominator missing. So this denominator already has an x plus 2, so it already has this guy, but it doesn't have an x plus 5. So that means I need to multiply this bottom by x plus 5. But hold up, anything I multiply to the bottom, I have to multiply to the top. So I had to multiply the bottom by x plus 5 because that's my common denominator. And then this one here, what do you think we have to do? Well, this denominator is missing the x plus 2, so I have to multiply this bottom here by x plus 2. So I have to multiply the top by x plus 2. Now, I'm not actually going to multiply these out just because I have it already set here. But I do need to multiply the top here. So this 6x will need to get distributed into the parentheses. So 6x times x is 6x squared. 6x times 5 is 30x. Okay, I just noticed something here. I totally forgot that this minus sign here, by the way, should be a plus sign. Let me fix that real quick because we're doing adding rational functions. So if you want to just change that minus sign to a plus sign, make sure you do that before we do this problem. We'll do subtraction in the next slide, but let's just do addition for now. So there's a 3 in front of this parenthesis, so I'm going to distribute that in. 3 times x is, oh wait, hang on, I forgot to bring my plus sign over. So there's a plus sign, plus sign. So if I multiply the 3, I get 3x. Try to make the colors consistent. 3x. And 3 times 2 gives me 6. And so when I look at this, let's see if I can combine any like terms here. So in the top here, I have a 6x squared. I don't have another x squared, so I can't combine. But I have two x's, 30x and 33. If I add them, these two, I get, let's see, 6x squared plus 33x plus 6. And then the bottom, I just have x plus 2 and x plus 5. And now when I look at the top here, I can't combine any more like terms. There's no more like terms. So in this case, this is my final answer. And this is one of those problems where you just have to get common denominators and then add the numerator and simplify. You don't need to try to cancel out with the bottom or anything like that. Just add or subtract. Okay, now let's take a look at subtraction. Okay, so for subtracting rational functions, one of the things you need to be aware of is to not forget the minus sign when you're working it out. So how I think of it is that if there's a minus sign, or when you're subtracting there's always a minus sign, you want to make sure you distribute this negative to your rational functions. And you'll see me doing that here in a sec. Also, I'd like to mention that when you are subtracting, it's very similar to adding. You gotta find common denominators. So two things, you gotta find common denominators and don't forget that minus sign when you're distributing. So let's start with this one. First, let's check if the two fractions can be even subtracted. So if the bottom have the same denominators, then you can start subtracting, but they don't. So that means we have to make a common denominator. So if we are choosing a common denominator here, if I think of these as factors, then I have x plus 2 and I have x plus 5. I'm going to take a copy of each denominator. Now I'm going to look back and see which one is this fraction missing. This fraction is missing the x plus 5. It already has the x plus 2 and needs the x plus 5. So I need to multiply the top by x plus 5. And then for this one here, this bottom already has an x plus 5, so it's missing the x plus 2. So I need to multiply the top by x plus 2. So you only multiply the top by what it's missing. By the way, I didn't multiply the bottom by what it's missing because in this case I know that I'm going to eventually get to these two and there's no need for me to write so much. So when I look at this here, I'm going to distribute the 6x into the parentheses. So that's going to be 6x squared plus 30x. Then I have a minus sign here. So what I'm going to think of this as is -3, and I'm going to distribute my -3. So -3 times x is -3x. Extend this a little bit. And then -3 times 2 gives me -6. Okay, so when I look at this here, I'm going to bring over my denominator. Let's see if I have any common factors here. Notice that I have a 30x and a -3x. So if I combine, I have 6x squared plus 27x minus 6. And that looks like my final answer because I can't really combine any more terms in the top, and the bottom's already in factor form, so I don't have to mess with it. By the way, you don't need to FOIL this out. You can keep it as factors. This will come in a little bit handy when we learn how to solve for rational functions on Friday. Okay, so looking at this one here, let's take a look at the denominator. Are the denominators the same? Yeah, they both have 5x cubed plus 10x squared. So that's telling me my common denominator has already been chosen to be 5x cubed plus 10x squared. They've already figured it out based off the problem. So when I look at this here, I don't have to do anything to the top. I just have a 4x plus 2. So I'm going to bring that over. I have a 4x plus 2. But then I have a minus sign here. I'm going to highlight that actually. Because I have a minus sign, I need to make sure I distribute this negative sign to each term in this numerator here. So that is -x plus 5, because two negatives make a positive sign. And so now when I look at this here, I'm going to see if I can combine any like terms. So the bottom, I'm going to keep it the same, 5x cubed plus 10x squared. For the top here, I notice that I have the 4x and the x. If I combine them, I get 3x, and 2 plus 5 gives me 7. And so when I look at this here, 3 and x, I can't combine any further. And the bottom here, I don't need to simplify. It's just my denominator. So in this case, I am finished. And then for the top, let's see if we can combine any like terms. So we have 4x and negative x. So that makes it as negative x. And then 12 plus 12 plus 15 is 28. Let me make sure I did that right, but I don't see any issues here. 12 plus 8, yep, is, sorry, not 28, 27. 12 plus 15, 27, yeah. And that's it. I can't combine these two together, so this is all. And then for the top, let's see if we can combine any like terms. So we have 4x and negative x. So that makes it as negative x. And then 12 plus 5, or sorry, 12 plus 15 is 28. Let me make sure I did that right, but I don't see any issues here. 12 plus 8, yep, is, sorry, not 28, 27. 12 plus 15, 27, yeah. And that's it. I can't combine these two together, so this is all.